when comparing these two molecules, the first thing you want to notice is that even though dashes and wedges are being used, these carbons are not chiral centers. Okay, they're not chiral centers because there's not 4 different groups attached. Both halves of the ring are identical, so we only have 3 different groups attached and they're not chiral centers. These are, however, stereocenters. Remember, stereocenters are atoms at which the exchange of 2 groups will give you a stereoisomer. Okay, so we can basically prove that, showing right here, when you exchange the chlorine and the hydrogen, you get this molecule on the right, because they're swapped positions. So these two are stereoisomers, because swapping that stereocenter, you get a stereoisomer. Okay, now another thing you can go ahead and note here, if these don't have chiral centers, they're not any type of special cases, these are achiral molecules. If they're achiral, neither of them have an enantiomer. So we can go ahead and cross enantiomers off of our list. Okay, so if you look at these two, they're certainly not identical, because if you tried to superimpose them, well, yeah, the top chlorine would line up to the top chlorine here, but at this bottom left carbon, you have an out chlorine, here you have a back chlorine, those wouldn't superimpose. So they're not identical. Okay, they're not constitutional isomers because they need a different atom connectivity for that, and they don't have a different atom connectivity. So really what we're left with is diastereomers. Not isomers, they have the same molecular formula, so that's really not one either. Okay, but remember the definition of diastereomers. Okay, they're non-superimposable. And we just said they're non-superimposable. They're also not mirror images. Again, even though the top chlorines, you might be able to make them try to mirror one another, but the bottoms won't.